One of the most basic properties of matter is mass, a quantity that determines how much resistance an object offers when a force is applied to it. The Higgs boson is the fundamental force-carrying particle of the Higgs field, which is responsible for granting other particles their mass. The Higgs boson has a mass of 125 billion electronvolt, meaning it is 130 times more massive than a proton, according to CERN. It is also chargeless with zero spin. The Higgs boson is the only elementary particle with no spin. A boson is a force-carrier particle that comes into play when particles interact with each other, with a boson exchanged during this interaction. For example, when two electrons interact, they exchange a photon, the force-carrying particle of electromagnetic fields. Quantum field theory describes quantum fields that fill the universe. Boson can also be described as a wave in a field. So a photon is a particle arises from an excited electromagnetic field. Similarly, the Higgs boson is the particle arises from the Higgs field when excited. That field generates mass via its interaction with other particles and the mechanism carried by the Higgs boson called the Brautengler-Higgs mechanism. Without the Higgs field and the Brautengler-Higgs mechanism, all fundamental particles would race around the universe at the speed of light. This theory doesn't just explain why particles have mass but also why they have different masses. Particles that interact or couple with the Higgs field more strongly are granted greater masses. Even the Higgs boson itself gets its mass from its own interaction with the Higgs field. This has been confirmed by watching how Higgs boson particles decay. One particle not granted mass by the Higgs field is the particle of light, the photon. This was a brief explanation, but advanced physics and mathematics is required to understand deeply about symmetry, violation, etc., and how Higgs field interact.